session. And fine. And let's go back to here again. So if you recall, last time we discussed how to actually solve a given problem using recursions, right? And we said if your problem is, if you're able to factor or kind of split your problem into two pieces, one, let's say a solution for, let's say, simple part of the problem, one size problem, and then the rest is actually split into another problem, which is kind of requires the same solution, but in a smaller size problem, then we can actually hope to do this using recursion. All right, so this is what we discussed. And our one of our example was the good example, or the simple example was this factorial. And you should remember that factorial is simply like this, right? So if I want to find the factorial of n, this is actually n times factorial of n minus 1. So what I did is I actually split my problem into two pieces. One is size 1 problem, which is this part, the current problem, and then the same solution that I would have for the original problem, but in size, a reduced size, a simpler size than original one. This might mean n minus 1, n minus 2, but it doesn't matter how many, but it should be a reduced one. And this is clearly the case here. You are actually multiplying n with the reduced size problem, n minus 1 factorial. Therefore, this is a very good candidate for recursion. And the answer to this one was very simple. The simple case where n is 0, my answer is 1. This is actually the base case, the smallest case, or the smallest problem that you should be able to see in this particular, in this type of. And then the rest is very simply the size 1 problem, solution to size 1 problem, which means I will multiply your answer to a size n minus 1 problem with my current number n, and that's it. Then this is actually a recursive or recursion, where I am calling the same function or the same solution with a smaller number of, let's say, or a subset of a problem, not my original problem, but the subset of my original problem. In this case, just n minus 1 factorial instead of n factorial, right? And if you recall, the way that actually C implements it, and the way that actually we can implement this in C and see how it works is simply this one. When I call factorial 3, right? 3 factorial function factorial 3, what this function tells me is that, okay, you'll get this thing, you'll have a local variable answer, and then check if n is 0, then answer is going to be 1. Otherwise, the answer is going to be n times the factorial, the same function called for, right? So this is the part of the code. This part of the code is for the first call for the factorial, which is 3 in this case. So n is 3, the set argument or the send argument is 3. Answer is gonna be, if you look at this, answer is locally defined, and n is not 0, therefore answer cannot be 1, else answer has to be n, so you can, answer is n times, this is n, the factorial of 2. Now, I go to factorial of 2, this is my factorial of 2 function, factorial 2. And factorial 2 function for factorial 2, n is 2, the send argument, the argument, this function is called with n2, right? Since cannot be 1. The local variable answer cannot be 1. It has to be, the local variable answer has to be 2 times factorial 1, right? So this will or the passes the control to the function, a new function called to factorial 0, factorial 1, right? So now factorial 1 has n is 1, still not 1, or answer is not, n is not 0, therefore answer should be 1 times factorial 0. So this is the case here. Then I'm gonna call this one, this guy again, the same function with factorial 0 this time, right? Now factorial 0, n is 0, therefore if you look at the code said if n is 0, the answer is 1 and returns. So n is 0, answer is 1, and it returns the answer. The return answer is 1. So this function called here, after the first return, this is gonna be replaced by 1 because factorial 0 returned 1, okay? Now, this is, you can now find 1 times 1, which is 1. Answer is 1, and you return the answer 1. Therefore, here, this is returned, and the answer is 1, okay? Now, answer is 2 times 1. This is sufficient for me to actually evaluate this. So the answer is going to be 2. Return answer is going to be 2. Therefore, this function call is going to result in 2. 3 times 2, which will be 6. The answer is going to be 6, and the return value for this function is going to be 6. Therefore, factorial variable is going to carry the number 6, right? So this is how it happens. Okay, we have seen quite a few different examples yesterday. Now let's look at another example. What I'm going to do is this time I'm going to look at, let's say, an example where I'm going to extract the capital letters from a given string. All right. So I'm assuming that sending this function a string. Since I'm not going to modify this string, I'm using the const keyword, saying that this is not a modifiable string in the code or modifiable pointer. Now, if I call this function with, let's say, string, something like this, all is fine, let's say, all right? Now, if this is a string, then this capital letters, the number of capital or the capital letters that is returned from this function should include A and capital N. So it will search through the string one at a time, and then it will extract the capital letters and put it in the answer. Now, what has to happen is that I have to have a local definition of my, let's say, of my. So let's do it this way. Since this is going to return a string, you have to send this an empty string where the capital letters is going to be held in. So this caps, the first argument is going to actually keep the capital letters found by the function. All right. Now, my base case is very simple. Let's start with the base case. The base case is saying that if you give me an empty string, my answer is going to be empty string because there will be no capital letters in an empty string, right? So what I am doing is I am answering your caps, your argument that is supposed to be keeping. I'm saying you don't need to have anything else because you are done. That's it, right? So then this is the first case, the base case. What if the function, the string is not actually empty? So let's say this guy. So what I need to do is I need to check the first, right? So I do check the first character of the string here, and I say, is this an uppercase? If that is true, what do I do? If that is true, what I do is I take this one and I copy it to my caps and then continue with the rest of it. And I continue with the rest of the string. So this is the size n-1 problem that I have. So what I do is I will call my string function with this second character and on. Not the first character, because I consumed the first character or I looked at the first character. If it is a capital, I extracted it. If it is not a capital, I forgot about it, right? Okay. Now this is the n minus size n minus 1 problem. So how do we combine this with my solution? My solution is in this case is gonna be very simple. I'm gonna take actually I wanna put my solution into caps. So caps is gonna get either the first character of this guy, so it should get something from this guy, something from this one character, and then it will add up the rest of the things that is coming from this part. So how can I do that? This is very simple. I can use a function or an append function if I want to, but I don't want to use append here. So what I actually do, I am printing the first character, which is actually, I know that it's a capital, right? And I am printing next to it all the things that I will find in the rest of the in the rest of the string. So I'm concatenating the first character with all the parts of the string, or all the capital letters that I'm gonna find in the rest of the string. So this is finding the rest of the string, the capital letters in the rest of the strings. If this works, actually take the current character, which I know it to be capital, I just combine them and I put them in caps. That's it, I'm done. Okay, if not, then I just call this function, recursive function, without doing this thing, because the first character here, I know that if this is else, the first character is not the capital one. So I need to be very careful here. Just here, I did something here. I need to send something to this to receive the rest of the characters, okay, or the capital characters in the rest of the string. I cannot send my caps, this, I cannot just send it there, because if I send it, what will happen is that the caps is gonna actually at the end is gonna be ending with a 0 here, or 0 character. So what I do is instead I use a temporary variable, a temporary string like this, and I actually keep the rest of the capital letters in this empty temporary string. And then once I find it, if I find it, I'm gonna use it. If I don't find it, I'm not gonna use it. Doesn't matter, right? But the answer to this guy is gonna be, this guy is returning what is it returning? It's returning cap. And since I am passing this guy, it will be returning the address of rest caps for the rest of the string. So if we trace this, for, let's say, Jojo input, and now enough, right now it's going to be empty, but I am assuming that this is long enough. In the beginning, it's going to be empty. Now, string is, when I call this first time, the find caps function first time, string is with 2 capitals in it. The first capital is, first letter is a capital, J is capital. Therefore, when sprintf caps, this guy is going to be put, and I will be finding the rest of the thing. But rest of the thing using this rest caps variable, a local definition defined locally in this block. So there is a caps in this block defined of size, let's say enough number of characters. If this guy, what I am expecting this guy to do is actually rest cap should return with a J in it, because in the rest of this character, O, capital J, O, you have only 1 capital letter. It could have been more, but in this case, there is 1. So I am expecting rest caps to return something with J in it, all right? So let's see what happens in this part of the code here. What is this gonna do? This is the second call to this function. The input is Ojo, OJ, O capital J, O. And O is not an uppercase letter, therefore it's gonna just call this guy. It's not gonna do that particular. If you recall, it's not gonna do that particular. See it here. This is gonna actually just use the caps and the rest of string. No string here. It will actually put in caps the capital letter and the right. So in this case, I don't need to actually send here in SS. Doesn't matter. Which is this string is indeed this res cap, right? Not the original string that I had here. Not this string or this string. Sorry. It's not this string. This is my caller actually defined a caps string. Here, I did a local definition of res caps or declaration of res caps with enough number of entries in it, and I sent this as a caps function, and then it will be sent. The thing it will be sent here. Still, this in this case caps, and if I do this enough number of times, I'm gonna hit here J. Therefore, I'm gonna do another res caps definition here. So this guy will have its own res, and it will call the next function with res caps. So here, then caps actually will be pointing to res caps defined in this block, not in this block or not in the callers block. So whoever called this function is gonna have a caps definition that has changed the caps, local caps changed.
Seste hala sıkıntı vardı hocam.
Because of the local definition here in this block. And then it has been changed also here. I cannot help with that, unfortunately. I don't know what to do. So what I'll do is, if the quality was not sufficient to understand the course, we'll repeat it, okay? Okay. So this is again one way of doing this. This is possibility, and it's actually a good one, which let me see, okay, which is gonna be the implementation of selection sort. And if you recall, the selection sort is actually a very simple thing. The selection sort, what it does is it says, okay, give me an array. This is the idea is a given array should be sorted in ascending order. Let's say assume that in this case we are gonna actually be sorting the. Okay, so what am I gonna do is my size 1 problem is find the largest number in the given array in the n array with n size n. Okay, this is this guy. Find the large number, this one, largest number, and put it in last. Or 45, put 45 at the very end. Now, once I actually, this is one problem. My size n minus 1 problem is now sort this. So I do very simply first find the biggest number, largest number in the array, in my original array, put it as the last entry, and then what you do is, once you do this one, then you call your function, this recursive call, to the smaller size array. This part of the array is not sorted anymore, right? I find a largest number to the last. Now I know that the last one is okay, but the first n minus 1 or first 3 is not okay. Just working on this guy. The same thing is going to happen. I'm going to look at this. My size 1 problem is just to find the largest number, which is 34, and put it as part of the list. And then once I put my n minus 1 size problem becomes just sorting those 2 entries in this case. And then once I actually sort those 2 entries, I am done. So the recursive version of the select sort is very simple. It says more than 1 entries, 2 or more entries in your array. You are given an array, this array, you want to sort it. And if your array has n entries, and if if the number of entries is more than 2, if you just leave it unchanged. This is clear, right? So if you have only one entry array, just one number in your array, then you already sorted. So if not, then what you do is you find the largest number in your array and replace the last entry as the largest number and swap the rest of it around, so that after this function you have last entry or largest entry. Let's do the this function is going to say largest entry in the array will be placed at the end of the array. So if I had 1, 2, 5, let's say 3, the array is going to become 1 per, have something like this, 2, 3. Okay, the largest number after this function. This is my size 1 problem. And if this is the case, then I can actually solve the rest of the problem by just taking the array and just looking at the same function, call the same function, place sort function, and just look at the n minus 1 entries. Last entry is already solved. I don't need to worry about the last entry. Just do the n minus 1 entry. Now, this means that just look at this part of the array. Once you solve this part, this is already solved, of course, then you look at this part. And then when you left only 1, you just get out. So this is a recursive version of selection sort. As you can see, this is a very, very simple algorithm, except that I haven't written the place largest yet. So I have to write that. But if I am to write the place largest, then this function has 2 statements, actually 1 if statement, and then 2 statements inside the if function. One is placing the large number at the end of the array and calling this select sort with the first n minus 1 entries. That's very, very simple, right? So if it's a place largest number, so it is clear that what you're going to do is, so for example, let's say if you have this, let's say something like, let's say this, you can do, you want to actually compare the last entry in an iteration, in a loop, with the first one. If this is larger, put it here. Otherwise, look at this guy. Otherwise, look at this guy. So you do a for loop, a simple for loop, and actually replace the largest entry with the actually the last entry should be at the end of this loop, should be just the largest entry. And you start from the largest entry and minus 1 entry and compare them. If they're compared, you actually just change them. And then at the end, you can swap them. So here, this is a little bit of a kind of a faster version of it. So what it is doing is it is finding, it is avoiding copying. So copying it, what it does is it finds the largest entry to the largest index to the largest entry. So if I have 1, 3, 5, 2, and 4, it will start from here. This is your max index. Max index is first 0, and then you compare it with this guy, and then you actually go for the rest of it. You compare it with this guy. If this number is bigger than your current index, you hit 2, in this case 1, sorry, 1. And next one is larger than that, so it will be, right? And this is not larger, this is not larger. Therefore, my largest number is going to be, the max index is going to be 2 in this edition, in this current one. And then what I will do is, I will just list the number with max index number with the largest number, the last entry, this guy. Just swap. Therefore, I'll do only one, and that swap is going to be only if it's larger than the index anyway, or the last number in my array. If that is not the case, then I do a simple. This will be kind of the most efficient way of actually doing this placement, placing largest number at the end of the array. Once this is done, then my code for recursion is this one. Just if I do this placement of the largest number at the end of the array, and then just on the rest of on the first n minus part of the array. You could have done it actually the other way around. For example, you could have find the, in that case, what would have happened is again the same thing. If n is larger than 1, then you would say place smallest in array n, the smallest entry to the, and then your select sort would have been something like this. Now you have to be a little bit careful. You cannot send n minus array and n minus 1 here and n minus 1. This will not it will actually take first n minus 1 entry. Therefore, you have to change this guy. This guy, taking the address. So you continue from second, and since you start the second entry or the rest of the array, you have only n minus 1 entry. So in the code, this will have the difference is going to be this part here, an address of array 1. It's not a big deal, but yet this is the very, very simple. You can see that now it kind of becomes useful to use recursion here because this code is simple. Otherwise, I would have actually written a loop here, and this loop will be more complicated than this. Is very simple to understand. You say, find my largest number, put it at the end of the array, and sort the first n minus 1 part of the array, excluding the last entry. That's it. This is very, very simple to understand. This algorithm is extremely simple to understand. And the coding also exactly as I would understand the thing, or as I would say the algorithm. Otherwise, I would say, okay, do a for loops counting from something and going to something and so forth. It is a little bit more difficult to follow the coding using a loop versus, in this case, the recursion is the simplest form that you can think of. All right. So recursive functions sometimes may give you very, very simple code to understand, to read, and to write. All right. All right. So let's look at quickly another example. What I want to do is I want to do set operations. I want to build a library, a simple library that will actually give do set operations. A set is given as a string, in this case, something like this. Let's say this is a set, A, B, C, for example. Or I could have another set, for example, like this. Let's say 1A, 2B, and so forth. So a set actually, string includes an open curly brace, a closed curly brace. It has to have it, right? So this is the definition. And I might have 10 digits, and also only uppercase, it says, and uppercase and lowercase letters. There are 52 of them, 26 times plus 26, 52. 10 digits, 62. 2 for curly braces, 64. And you have the end of string null array, end of string array, right? So indicator. So now, if I give you, for example, let's say a string like this, saying 1, 2, 3, okay, it's one set, and another set is, let's say, 3, 4, 5. Can you find me the, for example, union of these two sets? Of course, the union is 1, 2, 3, 4, 5. Can you find the intersection of these? It is 3. Can you say other things like, can you print this set? So there is one version of print set that is actually simple. Another print set with commas. You want to put actually commas like this, perhaps. And then you want to find the set union, intersection. And then maybe another problem could be, for example, I give you two strings representing two sets. And is the first string is a subset of the second string, right? Or is a given string a set at all? So how do I check? A given string should not have anything other than letters and digits, and also just a curly brace beginning and end. And it should always begin with a curly brace, and it should end with a curly brace. And by the way, I don't. I did a mistake here. I don't have the commas. Therefore, my string should be like this: 1, 2, 3, separated by space, and then perhaps 4, 5, right, like this. So in this case, for example, 1, 2, 3 might not be a set because this is not a set because it doesn't end with a curly brace. So there are isEmpty functions for actually checking if a set is actually empty. There is a isElement functions checking if a given character is a part of the set. There is an isSet function asking if the given string is a set. A subset function saying that a given string is a subset of another. And union. Union is going to return a new set or new string. You can do a print with commas. You can do a print, and then you can get perhaps just the set itself. Given a set, you can get a set. All right. These are the functions that we want to actually build. So, for example, let's say, look at if there is if the set is empty. Empty set means my first character is actually just null character, meaning I don't have anything. So here you could have said, okay, would an empty set? Of course, but they are assuming that this is not the case. All right. So isElement, I'm going to check if a given set has a particular character in it. This is very simple, but I want to do this as a recursive call. My problem is this: you give me a string, right? And I know that this is, let's say, a set, and I'm checking if a given element is going to be part of the string. I'm going to check the first character. If this is first character is the character that I am actually sending, I'm asking you, then I will say, okay, this is included. So if the set is empty, there is no answer, there's no possibility. if the set is not empty, but the first character is your first character is your element, then I return true. Otherwise, I return an answer that is actually looking at the rest of the thing. So I'm looking at the element in the rest of the set. So if this returns true, then the answer is going to be true. If the rest doesn't include your element entry, then this will actually return false. Okay. So let's take a 10-minute break. Hopefully the connections get a little bit better after this 10 minutes, and we'll continue with this, the other functions of this set operations. All right. So I'm stopping the recording, and we'll continue in about 10 minutes, around 2:28.